I'm Mr. Kangas, and today we're going to be taking a look at Chapter 9, Section 5, the distance formula. And in this video, I'm going to be talking about two things. I'm going to talk about how the distance formula, over here on the right, relates directly to the Pythagorean theorem. And I'm also going to talk about how it also relates to slope as well. And they'll both tie in together because slope also utilizes aspects of the right triangle and Pythagorean theorem as well. So when we take a look at the distance formula out here, I've done an example out for you. So instead of y1 minus y2 and x1 minus x2, I replaced it with actual numbers from a pair of coordinates. So if this is y1 and this is x1, so we have an ordered pair of 10, 5, and an ordered pair of 6, of 6, 2. Okay? So the question is, how far apart are these 2 points? Okay? And so you would plug these points into the distance formula, or as discussed in previous videos. And again, just to reiterate, this is y1 minus y2, x1 minus x2, if I was to write the formula out with variables. And we've discussed that in the previous one. I just didn't have enough room on the board to fit it, which is why it's not here. So the Pythagorean theorem looks like this. Okay, a squared plus b squared equals c squared. So the first thing you do over here on the right side in distance formula is you would need to subtract the numbers inside the parentheses. And once you do that, that's when this starts that's when you can start to make the connections between Pythagorean theorem and the distance formula. If you take a look at what's going on the right side here and what's going on the left side here, it's the same exact thing. What's happening here is when I subtracted my y coordinates, I got 3. When I subtracted my x coordinates, I got 4. Okay? Over here in the Pythagorean theorem side of things, what we've done is we've assumed we have a right triangle that has a side length of 3 and a side length of 4. Okay? And so when we're talking about a right triangle, okay, side length of 3, side length of 4. Okay? And we said that if you square both of those side lengths, it should equal c squared. Okay? So the first thing we have to do in Pythagorean theorem is square the 3 and square the 4. Well, the first thing I have to do over here now is square the 3 and square the 4. Same exact process right there, right? Second thing I do for Pythagorean theorem is add the 9 and the 16 and get 25. I add the 9 and the 16 over here as well as my next step, and I get the 25. Next thing I do for Pythagorean theorem is I want to know what c equals. Well, in order to know what c equals, I have to get rid of the square. How do you get rid of the power of 2? You square root both sides, so I end up square rooting the 25. And the square root of 25 is equal to c, because the square root of 25 is 5. Square root of 25 is 5. All that's happening over here in the distance formula is you're doing Pythagorean theorem for a right triangle where you are given a and b. Okay? This is Pythagorean theorem where you're given the sides of a triangle. And I'll explain how I know this is definitely true. Not only can you see the comparisons here, that they directly relate to each other and they do work, I'll also show you how this up here proves to us that these are the side lengths of a right triangle. And I'll talk about that in a minute. That has to do with slope. But if you just look at the comparisons, you can see the same exact things happening. The only difference between the two sides is over here, we kept saying that all of this equals c squared. And so when we got down to this final step, we had to square root both sides. We had to square root the c squared to get the c and square root the 25 to get the 5 to find out that the hypotenuse is equal to 5. Okay? And remember the hypotenuse is this line here. Okay? But over here, all that's happened is we know that if you take a look at what happened over here on the Pythagorean side of things, the c squared, nothing ever happened to it as I was doing my work until that final step. That final step, I had to square root it, and I got my c, and so now I know my hypotenuse is 5. On this side of things, what we're doing is we're saying that, we don't need the equals c squared. We know the end result of the equals c squared is going to force us to find the square root of what happens on the left side. So if you take a look at what's happening over here, not a whole lot happens. Okay? So someone said, okay, well, we don't need this. Okay? What's happening over here is we got rid of the equals c squared because we know in the end all that we're going to do to get our answer, which is 5, to get the answer we want, we just need to square root everything that happens over here. So everything that happens over here you can see in these 3 steps here, and we have the square root sign here to take care of this last step. We know in the end when we do all of this and we get to 25, the last and final step will be to square root it. The last and final step here is to square root it. So we replace the equals c squared with just the square root symbol. Okay? We took all of this away and just put a square root symbol over it. Put a square root symbol over it. Put a square root symbol over it. And we know that c equals 5. Okay? So these two things are the same. This is Pythagorean theorem and distance formula. They're the same, well, almost the same thing. The difference between the two is with Pythagorean theorem, okay, I can find the missing sides of any right triangle that I want. Okay, if I am given the sides of a right triangle, I can plug in the actual sides into this formula, and I can find the missing side. I can test to see if 3 sides actually make a right triangle with this formula. And I can also do something, the other thing that this can do is, like over here, like we said, these 2 numbers in here, this 3 and this 4, in distance formula, always represent the legs. So you're always given the legs of a right triangle. What you will never be able to solve for, like over here with Pythagorean theorem, if I'm missing one of the legs, okay, but I'm given one of the sides and I'm given the hypotenuse, I can still find what that missing side is using Pythagorean theorem. Distance formula won't allow me to do that. Because distance formula's purpose is slightly different. Distance formula's purpose is to find the distance between 2 points. Okay? 2 points make a line. Well, if you have 2 points, those 2 points will always make a line, and that line will always be the hypotenuse of a right triangle. So the distance formula is set up to find this distance. The distance formula is designed to find the hypotenuse of a right triangle. Because no matter what line I create, the other 2 sides I make to connect my 2 points will always be the legs of that right triangle. Okay, so here's leg 1, here's leg 2, here's the hypotenuse. This is what distance formula is finding me. Now, I said earlier that distance formula can be related to slope. Okay, and it can. Because if you take a look at what's happening in here, it should look familiar to you. We're doing y1 minus y2, okay, and we're doing x1 minus x2. Now, if you remember back to chapter 7, okay, slope formula, okay, the change in y over the change in x, going from one point to the other. So by doing y1 minus y2 over here, okay, so if I'm going to rewrite the actual distance formula with variables included. Okay, so what we're doing is we know we have 2 points, and the y1 and x1 represent one of their ordered pairs, the y2 and x2 represent the other ordered pair. So when I subtract my 2 y coordinates, what that is going to find me is this leg right here. It's going to tell me how long this leg is, because when you subtract 2 things, you find out what's between them. Okay? The y coordinates represent where these points lie on the vertical scale of the coordinate plane. So when you subtract the 2 y coordinates, you're going to get the vertical or the up and down distance between those 2 points, because subtraction finds you what's between 2 things. Since the y coordinates represent the vertical position of the 2 points, when you subtract the 2 y coordinates, you will get the amount of vertical space between those 2 points. The x coordinates represent the amount of horizontal space between the horizontal placement of the points, and so when you subtract them, subtracting the x-coordinates will get you the horizontal distance between those 2 points, which is the other leg to the triangle, the horizontal leg to the right triangle. So the y1 minus y2 is critical, and the x1 minus x2 is critical because what they do is they find you the legs of your right triangle. They find you the horizontal distance between your 2 points and the vertical distance between your 2 points. Once you have those legs, once you figure out what those legs are equal to, that's what like we did here. We did 5 minus 2, found out that the vertical leg in this case was a 3. We found out the horizontal leg was a 4. And then we said, well, take a look at what happened. When we find the vertical and the horizontal distance between 2 points, we've created a right triangle. Here's the line we want to find the distance of. Here's the horizontal distance. Here's the vertical distance, which is right here, okay? Vertical distance, horizontal distance. Vertical distance, horizontal distance between the 2 points, okay? You connect those 2 distances with the line itself, which we're looking for. Okay, we want to know the distance of this line, and you've got a right triangle. So once we get to this point, we say, oh, well, if I have a right triangle, I have 2 out of the 3 pieces, I can just use Pythagorean theorem to find out what the third piece is equal to. So that's why the rest of this is actually just Pythagorean theorem, okay, as I showcased before, which I can put that back up here real quick. Okay, if I had a squared plus b squared equals c squared, okay? We know these are the 2 legs of my right triangle, the horizontal and the vertical legs of my right triangle, so we replace those for a and b, because that's what a and b represent. They represent the legs of my triangle. Okay, what are we doing here? We're squaring both of them, so I get 9 and 16. Okay, just like what happened here, we squared both of these, got 9 and 16. We have to add 9 and 16. We have to add 9 and 16. Okay, we got 25 from both of them, on both of them, right? Last step here, I want to get rid of the squared, so what am I going to do to get my answer? I have to square 25. And I have to square c squared, and I get c equals 5. In other words, my answer is 5. My answer is 5. Okay, so distance formula utilizes both Pythagorean theorem and slope. It uses slope to find you if you have 2 points that make a line. The slope will find you the legs of your right triangle by finding you the horizontal distance between them and the vertical distance between them. Those 2 distances represent the 2 legs of your right triangle. Once you have those numbers in place, okay, you can then use Pythagorean theorem, which a distance formula does. Once you find the distances of the 2 legs in step 1, you then use Pythagorean theorem to find the third and final piece of the puzzle, which is the hypotenuse of that right triangle, and the hypotenuse is actually your line. So that's how those 2 things kind of mesh together to create what is known as the distance formula. So not something that you have to know in order to use the distance formula, but it gives you a heck of a lot more purpose when using it. Just one of the things I dislike about the way math is taught a lot is math is one of those subjects where you can go through grades K through 12 doing math for years and years, getting answers correct, passing classes, but not really understanding why your answers are correct. You know, why does distance formula work? Okay? Where is it coming from? What's it made up of? You know, when you understand why something works and what's it made up of, you have a little bit more purpose when you're doing something. It's not just someone told me this works, so I'm doing it, and when I do it, it makes them happy. It's someone told me it works, but they also explained why it works, and now I understand why it works, and so when I do this, it makes sense. That's the kind of understanding I'm looking for. So that's why I show you these things. Also, the other purpose of this is when you understand why and how something works, it's also more likely to stick in your memory long term. So you're more likely to recall it later down the road. So again, this video is here for you for multiple purposes, and there are good reasons for why I show these videos to my students. So please try to remember those as you watch videos like this, where I don't necessarily show you how to use distance formula, but I'm showing you the behind the scenes stuff about it. So the next video is actually going to be on Chapter 9, Section 6, which is on similar figures.